Welcome, geometry students, to the review sheet help video. Let's go ahead and get started with numbers. Well, all of these numbers here, okay? We got a lot to do, so let's get after it. Here we go. There's the assignment, and let's get started. Okay, the directions for numbers 1 through 4 say to classify the triangle by its sides and by its angles. So here we go. You are allowed to use just some estimation on the angles if you want to. So obviously, this is bigger than 90, so it's obtuse, and we have at least two sides that are congruent. So you can call this an obtuse. Well, I'll just move it out of the way for you. Here you go. You can call this an obtuse isosceles, and I would have no problem if you called it an isosceles obtuse. Either way is fine, okay? So there we go. Moving on to number 2. All right, now this one here, obviously all the angles are acute, and so it's an acute triangle, smaller than 90, smaller than 90, smaller than 90, and none of the sides are marked congruent, which means all of the sides are different lengths. So this triangle here would be a scalene acute or an acute scalene triangle. Okay, moving on to number 3. All right, this one here is has all three angles equal, which means that all three sides are congruent. So we could call this equiangular, we could call this equilateral, or we could also call it an acute triangle because all the angles are less than 90, okay? So totally your decision there, whatever you want to call this. Equilateral, equiangular, or acute, or all three, okay? Number 4. Well, right away, based on the angles, we know we have a right triangle, okay? And then secondly, we know that we have two angles congruent, and so we've learned that when two angles in a triangle are congruent, then their opposite angles are congruent. So their opposite sides are congruent. So this side here has to be congruent to this side here. So we have a right scalene triangle. Nope, that is incorrect, and I apologize. A right isosceles. All right, moving on to number, not number, that's wrong. Moving on to number 5. Okay, a bunch of angles defined here. Well, I've told you students before, my suggestion to you is to not start with angle A necessarily, but just go through and start finding angles. Okay, that's what I'm going to do. So here we go. I'm going to start here. This is a straight line, and this is a straight line coming off of it. So this angle here and this angle here are what we call linear pairs. So if this angle is 125, then this angle here has to be 55 because 125 plus 55 is 180. Okay, now notice that, do we have any parallel lines here? I don't think we do. So okay, what else do we have here? So this angle here also has to be 55 degrees. Now let's stop right there. Okay, now how do I know that? Because of linear pair. There, there. Okay, now students, please listen to me. We have learned that when two lines are cut by a transversal in such a way that corresponding angles are congruent, that we then know those two lines are parallel. Well, look what we have here. We have two lines cut by a transversal, and this angle here and this angle here are corresponding angles. Now, I'm not saying that we're going to have to use this later. We might not have to use the fact that we have parallel lines, okay? Or we might have to, I don't know. But I'm going to go ahead and mark that just in case I choose to use that later. So it is good to know. So go ahead and mark this line here is parallel to this line here. We might need that later, okay? All right, moving on. Let's see here. This angle here is 110. And so let's see here. That means this angle here would have to be 110 also, because parallel lines cut by a transversal, corresponding angles are congruent. This angle here and this angle here are a linear pair. So angle F would have to be 70 degrees. 70 plus 110 is 180. C would have to be 70 also. Okay, so this angle here, well, 70 plus 55 is 125. So this angle here would have to be 55 to give you a total of 180 in the triangle. Now moving on here. Let's see what we have here. Okay, this angle here is 70. So this angle here would also be 70 because they're vertical angles, and vertical angles are congruent. And notice this line here has a line coming off of it, so these two angles are linear pairs, thus they equal 180. So if this is 115, then this angle here would have to be 65, and then 70 plus 65 is 135, so this angle here would have to be 45 degrees, because 45 plus 65 plus 70 gives you 180, okay? So there we go. I've not listed these out for you like A equals, B equals, C equals, etc., but I have filled them all in there. So so students, what I did not do is I did not list out the angles for you beside the letters, but I've listed them all here for you, so that should be sufficient, okay? Okay, moving on to number 6 here. Okay, let's go ahead and do this the same way we did the last problem, okay? So here we go. The first thing that jumps out to me is this angle here is 40. So I know this angle here is 90. So 40 plus 90 is 130. So this angle here has to be 50. Okay? So there we go. Now this angle here is 90. This angle here is 50. So this angle here has to be 40. Okay? Now let's see what else we know here very carefully. We might have some parallel lines, maybe. Maybe not. Let's see here. Okay, one thing I've seen here, students, is I have linear pair. 50, this angle here and this angle here are a linear pair. So if this is 50, this has to be 130. And if this angle is 130 and this angle here is 30, then 130 plus 30 is 160. So this has to be 20 to give you a total of 180. All right. Now, if this angle here is 90, which it is, now watch this, then this whole angle here is 90. Okay? And this whole angle here is made up of 1, 2, 3 angles. So all 3 of those angles have to add up to 90. So I have 40, 20 is 60, so this has to be 30. Okay? Now, if this is 30, and this is 120, 30 plus 120 is 150, then this has to be 30. Okay? Now, watch this carefully. Here's a straight line, okay? And on the straight line, I have 2 lines coming off. I have angle 1, angle 2, angle 3. Now, all 3 of those angles have to add up to 180 because I have a straight line right here. So 120 plus 30 is 150, so this angle here would also have to be 30 degrees right here. Okay? Now let's continue on. Now students, to finish this problem, there's probably many ways to do it, okay? But let me show you what I saw. Watch this carefully. This triangle right here. Now please watch this. That triangle, that triangle right there, I'm going to write that down here like this. Okay? Now, I'm going to extend this angle right here. See it? Now we call that, this angle here is exterior angle. Got it? Now, this side right here that I've extended is this side right here. Now again, there's probably more than one way to do this. This is how I did it, okay? So there we go. Now, this whole angle here, which is this angle here, is 140. 50 here and 90 here. So 140 degrees. Now what we learned is this. Please don't forget this, students. We learned that the exterior angle of a triangle is always equal to the sum of this angle here, the 2 remote interior angles. So these 2 angles here added together equal 140. Well, this angle right here is 30. So this angle here is 30. So this angle here is 110. So there we go. Now, if I know this angle here is 110, then 110 plus 30 is 140. So this right here would be 40 degrees. Because 110 plus 40 plus 30 is 180. Okay? That's how I did it. I'm sure there's other ways to do it, but that's how I did that problem. Okay? All right, number 7. The directions for number 7. State the postulate or theorem that can be used to prove the triangles are congruent. Okay, guys, here we go. We have angle, angle, side, congruent to angle, angle, side. Okay, angle, angle, side, congruent to angle, angle, side. So the answer would be angle, angle, side. Okay, number 8. Now be careful on this one. We know that we have an angle here congruent to an angle here. We know that. And we know that we have a side here congruent to a side here. Okay? Now, one other thing you need to realize is we have right triangles here. So we have a right triangle like this, and we have a right triangle like this. Okay? Now, this angle here is congruent to this angle here. This side here is congruent to this side here. Now, they share a side here. They share this side, so I have this side here congruent to this side here. Now, it looks like you have, now watch, it looks like you have side, side, angle, congruent to side, side, angle, which is not allowed. You're not allowed to use this. However, when dealing with right triangles, you are allowed to use, remember, hypotenuse, leg. So I have a hypotenuse and a leg congruent to an hypotenuse and a leg. So the reason would be these two triangles are congruent because of hypotenuse, leg. Okay? All right, number 9. Now I think it would help us to split these two triangles up. So there's one triangle, and here's the other triangle. Okay? Now we're going to put this angle here, which is this angle here, congruent to this angle here, which is this angle here. Okay? And this angle here, which is this angle here, congruent to this angle here, which is this angle here. Now notice the two triangles share this side right here. So this side here is congruent to this side here. So we have angle, side, angle, congruent to angle, side, angle. So these two triangles are congruent by angle, side, angle. Okay, we have two parallel lines here, students. Okay, so whenever you have two parallel lines cut by a transversal like this, we know that alternate interior angles are congruent. So this angle here is congruent to this angle here. Okay? And students, notice we have a parallel line here, cut by a transversal. So we know this angle here is congruent to this angle here because they're alternate interior angles. So it looks like to me we have angle for this triangle here, we have angle, angle, side, congruent to angle, angle, side. And so these two triangles are congruent by angle, angle, side. Also, to take this a step further, you could state that this angle here is congruent to this angle here because they're vertical angles. And you could say angle, side, angle is congruent to angle, side, angle. That would also be okay. Okay, so two ways for that one there. Okay, number 11. Well, again, students, it's probably best to draw these two triangles separately than to keep them together. So very quickly here, let's go ahead and draw these two triangles together. Or separately, they are together. So here's one triangle. And then here's the other triangle. Okay, there we go. Now, notice we have this side here, marked congruent. This side here, marked congruent. This side here, which is this side, and this side here, which is this side, and then they share this side here. So 2 marks, 2 marks. So we have side, 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 congruent to side, side, side. Okay, so there's the answer: side, side, side. Okay, all right, moving on to number 12. Okay, let's see here. Now, number 12 probably I don't think it can be done for what I'm looking at here. Let's take a look and see. Yeah, it can't be done because here's why. What we have is side, side angle congruent to side, side angle. So we have this, but that's not allowed. I've proven to you guys why. I've taught in class, in your notes, why you cannot use side, side angles. So there's really nothing else we can do. There's no other angles congruent. There are no other sides congruent. So the only thing we can use here is side, side angle, and that's just not going to work. You're not allowed to use that. So you cannot, hold on 1 second here. You cannot prove that these two triangles are congruent. Now they might be, we just don't know, but we cannot say for sure. Okay, number 13. All right, more than likely it'd be helpful to draw these two triangles by themselves. And remember, students, if this is a right angle here, then obviously this is a right angle here. And we know that they share a side here. This side here is marked. This side here is marked. And we know they share a side here. So we know this side here is congruent to this side here. Now at first it looks like side, side angle, but it's not. Remember, when you have a right triangle, which we do, this is a right triangle here, and this is a right triangle here. When you have two right triangles, all that you have to have is a hypotenuse and a leg of one triangle congruent to a hypotenuse leg of another triangle. And we have that. We have a hypotenuse and a leg here congruent to an hypotenuse and a leg here. So we can state these two triangles are congruent by hypotenuse leg, okay? Okay, moving on to number 14. Now let's see what we have here. This angle here and this angle here, they're both right triangles, so we know they're vertical angles. They're both vertical angles, so we know they're both congruent, so they're right angles. Now, once again, students, I have a right triangle here and I have a right triangle here. So if I have a right triangle, again, look, students, all that I need is to have a hypotenuse and a leg congruent to an hypotenuse and a leg. And that's what I have. I have a hypotenuse and a leg here congruent to an hypotenuse and a leg here. And they're both right triangles. So yes, I can definitely state these two triangles are congruent by hypotenuse leg. Okay? Okay, moving on to number 15 through 18. Okay, 15 through 18 is ABE isosceles. Is ABE isosceles. Well, here we go. Let's take a look and see. In order for ABE to be isosceles right here, we have to have at least two congruent sides. And students, we don't have that. I mean, I don't know how long this side here is, nor do I know how long this side here is. Now remember, opposite angles, if two angles in a triangle are congruent, their opposite sides are congruent. Now this is 75 degrees here. If this is 75 here, then I can say this side here is congruent to this side here. Okay, but I do not know this angle here is 75 degrees. So I cannot state that these two sides are congruent. So if that's the case, I do not know for sure that this triangle is isosceles, because I do not know for sure that this side here is congruent to this side over here. Okay, so moving on, the answer would be no, I do not know for sure that it is. Now, list all of the isosceles triangles. Well, look guys, this triangle here has two congruent sides. So there's one, A, B, C. This triangle here has two congruent sides. Okay, so triangle BCD. This triangle here has two congruent sides, here and here. So triangle CDE. Now, as far as I know, that's it, okay? And yes, that is correct. So those three triangles here are the three triangles that are isosceles, okay? All right, number 17, I'm going to throw this out as a challenge to you guys. I'm not going to, well, I'll show you what the answer is. I have worked and worked on number 17, and then hopefully one of you students can figure it out, but I have not been able to figure it out, so I'm not embarrassed of that. This is a good chance for you guys to show me what you know, okay? But the answer is 25 degrees. And I have tried equations, I have tried writing this angle in, this angle, etc. I can't figure it out. So I'm throwing the challenge out to you guys. Hopefully someone can figure this out, okay? That the answer is 25 degrees. And then lastly, number 18 here. Let's take a look at number 18. Identify the obtuse triangles. Well, students, we're looking for triangles that have angles bigger than 90, okay? Now we know for sure, we can pretty well see this one here does, okay? Now, so there's one triangle, okay, triangle CDE. Now, remember, we don't know where they got this answer from, but they're assuming that you're working number 18 out after you solve number 17. So we're going to go ahead and put 25 degrees here. Now, in this triangle here, watch this carefully, students. This angle here, this side here, is congruent to this side here. Thus, their opposite angles are congruent. So if this angle is 25, this angle is 25. Now, same thing here. This side here is congruent to this side here. So in this blue triangle, this angle here has to be congruent to this angle here. So if this is 75 degrees here, this is 75. Now, this right here is a straight angle. And I have three angles coming off of this. 1, 2, 3. Well, all three of those have to add up to 180, okay? So 75 plus 25 is 100, okay? So this angle right here has to be 80, okay? Now, if this angle here is 80, then these two angles here have to be 50 and 50. Now, the only thing left here for us to look at would be one other situation. And students, that other situation would be this right here. Well, first of all, what I was trying to show you is this triangle here is not obtuse. Although, to be honest with you, I wasn't sure, but I had to make sure, okay? So this blue triangle's not, this one's not, this one is for sure. Now, look at this triangle here. Look at the triangle right here. That comes down and goes over. You might not have thought of this, but it's still a triangle. Okay, that triangle there. Well, this angle here is 105 degrees. 80 plus 25. And so triangle BCE would also be obtuse. Okay, so there we go, students. That would be it. Hope that helped. Let's continue on. Okay, students, on 19 and 20, I thought it was a little better to not have all of the tree right here in the picture and the water and all that stuff. So I have taken the triangle from 19 and 20, and I have just drawn the picture like this without all the background information, without the tent right here that you see and all that kind of stuff. Okay, so here we go. Question 19 says, is triangle MNO, this triangle here, and triangle QPO, this triangle here, are they congruent? Okay, well look, first of all, it says in the directions that O is the midpoint of NP. So if O is the midpoint, then I know this. If O is right in the middle, then I know this segment here has to be congruent to this segment here. Has to be, okay? So I put a mark here and a mark here. Now, it also says in the directions that MN is perpendicular to NP, so I know this is a 90-degree angle, and it says the same thing here about NP and PQ. So there we go. Now, I know that vertical angles are congruent, so I know for sure this angle here is congruent to this angle here. Now, having said that, question 19 says, is this triangle here, we'll call it triangle number 1, congruent to this triangle here, triangle number 2? Well, yes, most definitely, because I have angle, side, angle congruent to angle, side, angle. So yes, number 19, yes, the two triangles are congruent, and the reason is angle, side, angle. Okay, now number 20 says, what segment would you measure to determine the width of the river PQ? Or excuse me, of the river. Now, here's the river running through here. Okay, as you can see. If you look in your book, you'll see here's the river running through here, okay? So, theoretically, if I want to measure this segment here, what segment would this segment here be congruent to in this triangle over here? Well, the best way to figure that out, probably, and I know it's just kind of common sense, you can see that this side here is going to be the measure of this side over here, but I would still encourage you to draw a congruent statement very quickly, like triangle MNO is congruent to triangle. Now, M is first, it has no mark. Which angle over here has no mark? Q. N is second, N's a right angle. Which angle is the right angle over here? P. And then, of course, O has 2 marks. So what angle has 2 marks over here? O. Now, MN, this segment here, right here, is congruent to what segment over here? QP or PQ. So at number 20, what segment would you measure that would be the same length as this segment here? It would have to be segment QP or segment PQ. Okay? That's number 20. Okay, moving on to numbers 25 through 28. Now, this is a pretty good problem, and it was good for you guys to have to do this, okay? Now, first of all, I'm going to plot the data on graph paper. I'm just going to quickly draw a coordinate plane here, okay? If you didn't have graphing paper, that's totally fine. That's not a big deal. Okay, so here's my tick marks. And here we go. Over 10, we'll call each of the x's 1. And we'll call each of the y-axis 10. Okay? And we'll have to put some more marks on here real quick. So, let's go 10, 20, 30, 40, 50, 60, 70, 80, 90. So put them a little closer together. So 10, 20. Okay, here we go. Now, here's the first ordered pair right here, and it's over 0.3 and up 10. So over 0.3, but right here and up 10. The next ordered pair is over over 0.7, so about right here and up to 20. The next one's over 1.1, 1.2, up to 30. And the next one's over 1.6, so right here, then up to 40, but right here. We're getting a pretty good linear relationship. So the next question is y a linear function of x? And so we're going to check in a second and see. Let me quickly finish plotting these. So over 2.3, and then up to 50, and then over 3.4, and then up to 60, but right here, and then over 5, let's see, 5, 3.4, and then 5.4, and up here. So it looks like it's not super linear. It's kind of curving a little right here. Okay. Now, here's the thing, guys. Whenever you're checking to see if a situation like this is a linear relationship, notice this, guys. Please listen to me carefully. As your y's are all increasing by 10, like this, then all of these should be increasing by the same amount. So let's see, going from 0.35 to 0.72, that would be a point, 27 approximately increase, I believe. No, 37. And then from here to here, the increase would be 28.43 approximately, guys. I'm rounding. And then from here to here, the increase would be about 0.52. And as you can see, guys, as the y's are increasing by the same increment, 10, 10, 10, the x's are not increasing. It should be 0.37, 0.37, 0.37, or 0.43, 0.43, 0.43, or 0.52, 0.52, 0.52. It should be the same as the y's are increasing by 10. All of these should also increase by the same amount, and they're not. So no, we do not have a linear relationship. No, okay? So first of all, we've done the graph, okay? Next, it says here, see margin, but the answer is no. They are not a linear relationship, okay? Now, we're going to take our graph here, and we're going to estimate the value when x is way out here at 18. And that's not going to be super, or when y is 18, okay? So let's see if we can do that real quick, okay? So when y is 18, what would your x be over here? Well, let's see. Here's 10, 20. So right here, and watch carefully, guys, use the graph to estimate x when y is 18. So here's y. We're going to go up to 18. Remember, these are in increments of 10. So 10, 20, 30. So 10, 18 is about right here. So go over to the graph right here, right there. What does that equal with on the x-axis? Well, it looks like it's about 0.6. So I'm going to estimate it's about 0.6. That's my estimation, okay? Now, for number 28, estimate the value of y when x is 0.8. So I'm going to go over here to 0.8 and go up. It's going to be right a little bit over 20. I'm guessing maybe 21. Okay, let me do that again for you, okay? Go over to 0.8, which is really hard to do, about right here, and then go up. I think I'm getting a hair above 20. But again, these are estimations, okay? Let's see how close I was. Not too bad. So I estimated 0.6, and the answer is 0.7. I said 21, and the answer is 21. Now, on a test or a quiz, I would have definitely given you credit for this or for this here, either one of those, okay? Totally fine. But that's how you would do this. If this is confusing, especially for those who have only had Algebra 1, You might want to back this up and watch all this again, okay? Okay, moving on to numbers 33 through 36.